We've got a whole lot of information here in this problem to use to sketch our graph. The nice thing is we don't have to go through that long process of finding the derivative, setting it equal to 0, putting it on the number line, plugging in things. All of that's kind of given to us. So that work is kind of set aside. We don't have to worry about that. We have to just kind of interpret this information in order to sketch a graph. So let's look at the first line of information. What is that telling us? What is that giving us? Points, right? Those are giving us points. We have a point at 0, 2, and then we have points at negative 2, 0, and 2, 0. Right, so it's giving us points. Let's go ahead and graph those points. So we're at 0, 2, and then negative 2, 0, and 2, 0. All right, our next line tells us some values of derivatives. Derivative of negative 2 equals the derivative of 0 equals the derivative of 2. They're all 0. So what is that telling us? What is it when the derivative is equal to 0? We just wrote that up top. Those are critical values. Right, those are the numbers we're going to put on our first derivative number line. To find those intervals when it's increasing, decreasing, find the minimums and maximums. So at negative 2, 0, and 2, the first derivative is 0. Now, normally we'd have to pick numbers, plug them into the derivative equation to figure that out, but we don't have an equation here. We just have other information we can use to figure that out. These next two lines tell us when the derivative is positive and when the derivative is negative. So it helps us fill out our table, or our number line. So derivative is positive when x is between negative 2 and 0. So it's positive here. And it's going to be negative when x is less than 0. When x is less than negative 2. Or when x is greater than 0. So in both of these intervals, the derivative is negative. So from this, we can figure out, okay, the graph is going to be decreasing first, then increasing, then decreasing, and then decreasing some more. So we can get kind of a basic idea of the shape of the graph. We can also get where the minimums and maximums occur. So what's happening at negative 2? Minimum, a maximum, or neither? At negative 2. Negative 2 is one of the three choices, a minimum, a maximum, or neither. Minimum, right? It's changing from negative to positive. Just put that right on the top of your sheet there. When the derivative changes from negative to positive, we have a minimum. Over here, we already plotted that point that was given to us. So this point right here, when x is negative 2, that's going to be a minimum on our graph. How about 0? It changes from positive to negative. So what are we going to have? Local maximum. So this point here is going to be a maximum. And at 2, it doesn't change either way, right? So it's not going to be a minimum, not going to be a maximum. All right, we have one other set of information here that deals with the second derivative. So this is going to help us come up with our second derivative number line. So our second derivative is going to be positive when x is less than negative 1. So we'll put negative 1 on there. It's going to be positive to the left of that. Or between 1 and 2. So 1 and 2 are going to be on here. And it's going to be positive in between there. Second derivative is negative between negative 1 and 1. And when x is greater than 2. So from this number line, we figure out when f of x is concave up or concave down. So the positive means it's going to be concave up, then concave down, then concave up, then concave down. And it also tells us the inflection points. Remember, inflection points occur when the second derivative changes. So each one of these is actually an inflection point. All right, they're all inflection points because they're changing signs at each one. If it doesn't change signs, like over here, if we have this happening on the second derivative, if it doesn't change signs, it's not an inflection point. Just at that point, yeah. So you look at each one individually. Now, x equals 2, that is already on here, right? This inflection point is already graphed. But the other ones, there aren't any points graphed for us. So we have to kind of come up with them ourselves. So those, we kind of have a range of possibilities. Well, let's look at the first one. X equals -1. There's going to be an inflection point when x is -1. So we need to figure out where does that point go. Could I put -1 way up here? Would that make sense? Why not? There's already a max right here, right? If that was up here, the max would no longer be at this point, right? Could I put our inflection point down here? Because there's a minimum there. If I moved this point down here, that would no longer be a minimum. So when creating this inflection point, it has to be between our maximum and our minimum, right? Can't be the same level, can't be higher, it has to be in between somewhere. Easiest way is just to kind of find the midway point. It doesn't have to be right in the middle, but it's easy for graphing. So I usually put it kind of right in the middle. So that's going to be an inflection point. Then at x equals 1, we're going to have another inflection point. Same thing. We have a max here. We have an inflection point. It cannot be above the max or below the inflection point. It has to be kind of somewhere in between. So I'm just going to put it right in the middle. And so now we've gotten through the first 5 steps of this process. Last step, we're going to use the graph's concavity to connect the dots. All right. So when we look at this concave up, when you draw a part that's concave up, it's going to look like one of these 3 things. It's going to be kind of a U shape, or like half of a U shape. We use the full U shape if there's like a minimum that we're going through. If we're going through a minimum, then that minimum is going to be like at the bottom of that U. Or for the concave down, we're only going to use like the full upside down U if we're going through a maximum point. Otherwise, we're only doing like half of it. So hopefully that'll make a little more sense once we kind of go through this process. Let's take a look at the first interval. Until we get to -1, until we get to this inflection point right here, our graph is going to be concave up. So it's going to be concave up until we get here. We're going through a minimum to get there. So that means the minimum is going to be like the bottom of that U. So this is just that first part. All right. Then it's going to be concave down from -1 to 1. So from this inflection point to this inflection point, it's concave down, and it goes through a maximum. So that maximum is going to be the top of that U. Then we're going from 1 to 2. From 1 to 2, it's going to be concave up. But there's no minimum or maximum on the way. Right? So we're not going down and then back up to this inflection point, because then we'd create some other minimum. But there is no minimum there. So this is where we only do like half of the U. So we're just going from here to here, kind of curved. We're not going down and up. We're just doing kind of half of the U. So we're doing this up here. And then the last part, from 2 to infinity, it's going to be concave down. So again, we're not going through a minimum or maximum. We're just going to do half of a concave down curve, like half of a parabola, basically. And that's the graph of our original function. So this is the original function, y equals f of x.